welcome back to the video series where I will be showing you how to program a top-down game using Processing 3.5.3 programming language. In my opinion, Processing is the best programming language to start out learning programming because it makes graphics very easy and it provides a bunch of easy to follow examples. Um, in my opinion, the best way to start is just to open up some of these examples that processing provides and then start modifying the code to see how everything works. Um, and one of the great things is if you learn processing, it's actually a subset of Java, so you'll actually be learning the Java programming language, which is quite useful and profitable programming language to learn. So anyways, I'll be teaching you how to program this top-down game, like an action RPG game. In the last episode, I created a scrolling system for the map and displayed like a player on top of the map, so you can walk around and it scrolls the map, but it doesn't move the scroll. It doesn't scroll off the edge of the map. So yeah, so you can see the player, well, he moves around quite fast right now. I made him go really fast just to be able to test out the boundaries of the map. But as you can see, it's a large map. It's 50 tiles by 50 tiles, and it scrolls um, up and down, left and right, and it doesn't the view of the map doesn't go off the boundaries of the map. It constrains the view to the boundaries of the map so that you can see the player still can move around. Um, so now what we're going to do is add some animation to the player so it looks like he's actually walking around. And I'll probably also show you how to read data from a file for the map so we can make it look different than this, not like just a random set of tiles. So let's get to it. What we want to do is create a class to do the animations first. If you look at the player, it uses right now a P image to display the sprite for the player, the image for the player. This is just a very basic image. It just is one frame that it has, so it doesn't have the capability to do any animation yet. So we have to build a custom class to do animation. Um, Processing does not provide any any standard classes to do animation with, so you have to make it yourself. Um, so so basically what we're going to do is we'll create an animation class. Actually, I'm going to create two classes. Let me show you how I'm going to kind of design this here. So what I'm going to do is I'm going to create a class called center here. So I'm going to call it the class animation, and this is going to have frames for the animation. It's going to define the frame rate, and it's going to, that's pretty much all it's going to define, just the frames and the frame rate for the animation. And it's going to have some methods in it to basically just to load the frames, and it's going to have a method to display whatever frame that it's on, and then it's going to have a method to I'll call it animate, which will actually animate, so it'll go through the different frames. So that's pretty much what the animation class is going to consist of. I'll make that bold so you can see that's like the name of the class. And then what I want to do is create a class. I'll call it Sprite. I'm not sure if this is like the best way to use the term sprite, but whatever. This is how I'm going to do it. So the sprite will basically, it'll contain an animation, and further it will contain the position in the world of the animation. And the reason that I want to do it this way is if you can think that let me see here, I'll create shapes, because these are the classes. From the classes you create objects of the class, which are like instances of the class. So basically we're going to have a number of animations. We'll call it like animation 1, animation 2, blah blah blah. Let's say we'll do just 2 animations now in this example. So what we want to do, we'll have a couple of different animations. We'll have more sprites. As you can imagine, the sprites will have their own positions. So we'll say we'll call it like the player sprite will be one of them, and then you can imagine there'll be like enemy sprites. So let's see here. So we'll make two enemies in this example so far. I'm not going to program the enemies in this video. I'll probably program enemies in the next video, but this is just to show an example of like why I'm planning to do it this way. So basically, well, let's see. We'll call this one actually just so make it better. So we'll say this is a player animation, and this is the enemy animation. Okay, so these are both, we'll make this a different color so you can see that like these are the animation class. So animation class here, these are objects, instances of the animation class. So the player will point to its player animation. It'll use this one to the player sprite, the sprite classes. The player sprite will use the player animation, and basically what the player sprite will do is it'll have a position. Along with this animation that it uses. So like you see, like this is the animation that it would point to over here. This animation, and then it has a position. So you can you can basically like control the location of the sprite. And the thing is, with the animations, you can actually reuse the same animation for different sprites, which makes it nice because you can kind of like save memory. It's just like optimize. You don't necessarily need to save memory like in this day and age when you're programming like this, but it can potentially optimize the speed of the game if you only like recycle one animation over and over again. Anyways, this is what I'm going to do for now. There's different ways to go about doing this, but the two enemies they'll share the same animation, and you'll see kind of how this works. They'll both like animate at the same timing. All the enemies, whatever sprites use the same animation, it'll all animate at the same time. Um, but they'll be able to move around in different positions, so you'll be having different positions. That's basically how it's going to work. You'll see kind of what I mean later on. But anyways, that's how I'm going to design this. You can design it in different ways actually, but this is how I'm going to design this for now. So first off, I'm going to create the animation class. That's going to be the more basic class here. So I'll put that down at the very bottom because this is going to be something that I'll use a lot. I'm only going to really program it once, and I'm not going to need to modify it very much after that. So let's say animation with extra one class called animation, and the animation is going to need a an array of images. So we'll call it images. Actually, let's call it frames. And it's going to need the number of frames that it uses. Let's see here. Looks like that is a keyword of the program. So I'm gonna call it images instead. Images. Image count, and it needs to know the current frame that it's on. So frame, and it needs to know the frames per second. Let's call it FPS. An abbreviation is commonly used. And then it also to actually do the animations, it'll need to do some timing. So I'll make it long last time. Long value is just a very long number. It's like a very large number. The integers, they can only go up to like I don't know, a specific number like 300 million or something like that, and then long they can go really really high. So um, so anyway, so what I'm going to do is create a constructor function that you can call to actually load. So I guess let's see, we can pass in the array of images, p image. Or no, actually we'll pass in a string, an array of names to use for the images. So images, call that was image names. We'll call that and then we'll tell it how many that we want. So int image count. This is a naming convention that I'm using here. I for initial image count. And then let me see, it'll start at the same frame. We want the IFPS, initial frames per second, to use, and that should be good. So what we want to do is we set the FPS equal to frames per second. We'll set the image count equal to image count. We'll set the frame will set equal to 0. Maybe I can make another function later on that you can start it off on whatever frame that you want. And then so FPS equals, oops, that's not what FPS equals, okay. And then let me see, what do we want here? Last time. Okay, so last time equals milliseconds equals milliseconds. Okay. Function whoops, what did I do that for? Okay, milliseconds. So that basically it sets the last time value to the time that the animation was initialized. This will allow us to do just allow us to do the animation. Basically, we need to know the time. We need to be able to keep track of time, basically, in order to know like how many seconds have elapsed. That's the only way that we can use the frames per second and actually make it, you know, really actually correspond to seconds in real life. So let's see here. So now what we need to do is load the images. So we'll go for I equals 0, I is less than, and then this is going to be the image count, image count, and then I plus plus. So we're basically going to loop through all of these image names. This is going to expect this array of strings to have the to have this number of items inside the list. So we'll say image names I. Sorry. What we want to do is actually set the images. Whoops, sorry. Actually, what we need to do is images equals new. New p image, and that will be image count. So we're just creating a new array of p images. We're making the array image count, this number, whatever, how much that number is. We're going to make that many images in the list. So then we can say images for each images sub I equals load image, and then it'll pass in the string of the image that we want to load in. So that's the image names. So that'll be the file names basically. So then we want to make a function to display the images, so void display, and all we need to do here is to image, oh whoops, actually we need to pass in the parameters of where we want it to display, or I'm sorry, we do p vector position, and we'll say image, this will be images sub frame, so whatever frame that we're on, we're going to display it at position.x and position.y. Alright, that should be good. And then what we want to do is actually do the animation function, so animate, and this will just increment the frame depending on how much time has elapsed. So we're going to call this continuously, and it'll just increment the frames based on the frames per second. So okay, so I'm actually just going to look at the other code that I had over there while I'm doing this, because it's a little bit complicated. It's hard to think about it while I'm actually talking at the same time on the video. So we want to do if frames per second is greater than 0, just to do a check, just to make sure that it was set correctly. If the frames per second was actually set to 0, we can use that to make it just statically display. We can make that just go as fast as the frame rate. So that's I think what I did now. So frame equals frame plus 1, and then mod image count. So this the modulus operator, this basically it takes it increments the frames, and then it gives the what do you call it, the remainder of an integer division against the image count. So it's basically like whatever this number is, frames divided by frames plus 1 divided by image count. So if frames plus 1 is anything less than this number image count, then it'll return, then this modulus operator will return the remainder. So it'll be basically the integer division will be, you know, frames, like a number, like say like the image count is like 10 or whatever. So if you say like 6 divided by 10 is going to be like it's a decimal number. So you're talking about integer division, it's going to be, you know, that's less than 1 but greater than 0, so that can be represented in an integer. So basically the result, the integer result of that division is 0, and then it has a remainder of whatever this number actually is. So it's just going to return whatever this frame plus 1 is each time. So, you know, it's going to be like 1, 2, 3, 4, 5, 6, 7, 8, 9, and then when it gets to 10, then it's going to return 0. Because basically, as you remember, the in an array, the index starts from 0 and it goes up to 1 minus the length of the array, which is image count, is the length of the array. So if it's 10, if there's 10 frames, if there, you know, 10 images in that array, that means that the indexes will be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. That's 10 altogether, starting at index 0, and so that, you know, that modulus operator will return 0 through 9, and it'll never go above 9. And basically, like once frame plus 1 is equal to 10, then this mod image count will be 10 divided by 10, which will be equal to 1. It returns the remainder, so it's 10 divided by 10 is equal to 1 with a remainder of 0. So it'll return 0, and then 11 will return 1, 12 will return 1, because it's like, you know, the division will be 1 remainder 1 for 11, 1 remainder 2 for 12, 1 remainder 3, blah blah blah. So you get how it works. It's kind of a, you know, very commonly used programmer trick here, is to use this modulus thing to make things kind of loop around based on a certain limit, which will be the limit with the image count. All right. So anyway, so that's essentially how you advance through the frames. If the frames per second is greater than 0, then we actually have to take into account the frames per second. This is basically just advancing the frames with no care about what the, you know, how many frames per second is supposed to be. It'll just go as fast as the screen is able to output frames, as fast as the program is able to output frames, basically, whatever that happens to be. So so anyway, so to get control over it based on the actual time, and use the frames per second value, we need to do some math here concerning time. So we need to calculate the amount of time that has elapsed since the last time, which we set initially. We set it when we in this constructor up here. The last time we initialized to whatever time was whenever we initialized you know initialized this animation. So to compute the time since that last time, it's the milliseconds, which turns the current time in milliseconds, minus the last time in milliseconds, and if that's greater than 1,000, so it's 1,000 milliseconds is equal to 1 second, which is what it's saying. If it's greater than 1 second, I'm sorry, 1,000 divided by FPS. So that'll be, one divided by however many frames per second that you want to do. So it's going to give you like time increments of whatever the amount of milliseconds it is that each frame will display for based on the frames per second. If you can imagine that. So inside of here, what we want to do is we want to set the frame equal to frame plus 1 mod image count. So basically, like, we're just checking each time has the amount of time that's elapsed gone past whatever this time increment that we're looking at here, based on the frames per second. If it hasn't, then it just doesn't do anything. If it does, if it is past that amount of time, then it'll advance the frame and it will set the last time equal to the current time here, what it is. So basically it resets the last time to this time, and then it checks over and over again to see if the time that's elapsed since it was last set here is greater than this whatever 1 second divided by the number of frames per second that you want. So this isn't the best way to do it, really, because if you can imagine, like, if your screen output like lags for more than whatever this increment of time is, say you're doing 10 frames per second, so that would be 100 milliseconds. So if your output lags for more than 100 milliseconds and it doesn't call animate, call animate within 100 milliseconds, then you imagine like it should advance 2 frames basically, but it's only going to advance 1 frame. So this isn't the best way to do it, really, but for our purposes, like, we don't really care. This is just kind of a down and dirty, easy example to kind of give you the general idea of how to do it. So if you want to figure that out, how to do it the better way, on your own time, you can figure that out. But this is totally sufficient for just making a game like this. I mean, you don't need necessarily, for what we're going to do, for the way I'm planning this, it doesn't need to be any better than that. So that's I'm just going to make it nice and simple like that. So that should be it. I'm going to go ahead and just try to run the program again just to make sure I didn't have any coding errors. So nothing changed in the program. I didn't actually like call the functions that I created. I just wanted to make sure that I didn't have any like typos or whatever inside of my code. That's why I ran it. So and that's a good habit to be in, by the way. I've said that in other videos, but it's a good habit to anytime you make a change, always try to run your program if you can, if it doesn't take too long, and that'll help you check if it actually made any mistakes or not before you get too far, and then it becomes difficult to find the mistakes that you made. So anyway, so we got the animation. So what we want to do now, we'll go ahead and we'll create the sprite class. And as I said before, the sprite class will just basically add on a position to the animation. Later on, we can expand the sprite class to do like effects or whatever, maybe, I don't know, some stuff like that. Anyway, so the sprite is going to have, for now, it's going to have one animation, and it's going to be, we'll call it A, or we'll call it animation A, and it's also going to have a position, so we'll call it P vector position. Okay, so one of the things you might be thinking, like, maybe is that kind of redundant to make a position for the sprite and also for the player. Not necessarily. You might want to separate, like, the player is more kind of like what the physics are of the of the object, and we can even separate like out the position of the player. But the player position kind of handles like I don't know. Basically, what you can do some cool effects if you separate out the player's position from the sprite. Like say you want to make it like shake around or something like that, then you can you make the player like move in its one position. That position stays steady, but if you want like a visual effect of it shaking around, then you can actually like alter the sprite's position a little bit as like an offset of what the player's position is, so the player can move and then the sprite can like shake around. So this is the reason why I'm doing this, making this two different kind of positions to display the sprite for the player. It allows you to do little effects and stuff like that. So let's see here. It also allows you to compose the player of like multiple sprites. If you can imagine, like I have like a sprite for like a head, and a sprite for the body, and a sprite for the arm, and a sprite for the leg. A sprite for the arms and a sprite for the legs. Then you can like position them in different places and do cool stuff like that. So it just allows you to do all kinds of neat stuff if you kind of separate it out like that. So anyways, let's go ahead and we'll create the constructor for the sprite. So sprite, and what we want to do is in the sprite actually we'll specify the animation IA, and we'll also specify the position I post. Okay, and then pose equals I post, and so A equals IA should be fine. Okay, so actually, I'm not gonna call this A. I'm gonna call it image. 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 Okay. I'll make it a little bit easier. So I'm not gonna build in like display functions and stuff like that into the sprite. I'm just gonna reference this image directly from the player and the position from the player. I think that should be fine for now. All right, so the player now, instead of having a p image, it's going to have a sprite, and it's going to be called sprite. And let me see here. So the sprite will equal. It's not going to do load image anymore. This is the player's constructor function where you initialize the player, you construct the player. It's going to take in a new sprite, and that sprite is going to take a. Well, actually, what we're going to do. Well, okay, for now I can do it this way. New animation, and I'm gonna also set the position. So the position will just be the same as the player's position. So the animation, that's going to be. Let me see here. We can specify the array of file names here. Let me actually look at what I have. So these are the file names actually I have for the player. You can see what they look like. Boop. Boop. Player walking. Yeah. Nice, very nice. Okay, so really basic sprites. I created these. You can download these, by the way, on my Patreon page if you want to check that out. So you can use this instead of having to create your own, which is kind of a pain to make it look nice. So anyways, what I'm going to do is I'm just going to copy the file name. These are all PNG files, so I can do transparency. PNG. Actually, I'm gonna separate this out into multiple lines. So I'm gonna make this a little bit bigger here too. Separate this out multiple lines so that you can so you can easily mess up this. This is here, and I'll set the position down here. So cool thing about Java, you can separate these out multiple lines if you need to. So, anyways, there we go. Alright, I'm just gonna put like the quotation marks here, so I just paste in the names here from the file folder. It's easy way to do it. So, PNG. Alright, I think that should be good. And so yeah, so then it takes another parameter here. I'm not sure if that'll actually work, but let's see what happens. Okay, so the new animation takes the array of sprites or takes that array of file names, and then it takes the number of the number of images, which is 4, and then it takes the frames per second. Let's say, actually no, I'll make this make it go 10 frames per second, which I think is good for this animation. We don't really want it to run very fast because it's only 4 frames. Let's see here. So what do we need? Images, image count, frames per second. So it looks like it's not letting me do this, set the image names this way. I'm not really too sure why. Okay, let's see if that one works. I'm not too sure if that'll work, but let's see what happens. What else we have to do also is we have to alter the way it displays here. So for the display, we'll say sprite.image.display, and that'll display at the sprite's position. We'll say the sprite.position equals dot x equals and sprite position dot y equals this. So basically just displaying at the same coordinates that we did before. Actually, no, I think I'm going to make a display function in the sprite after this. I'm going to just test this out real quick just to make sure everything else worked. But yeah, I think I'm going to make a display function for the sprite because this is just too much of a pain. That takes a p vector. Okay, sprite pose. Okay. Okay, I think that should be it. Let's go ahead and test this out now. Okay, yeah, so now you can see the player is displaying, but it's not animating, and whoop, I don't know what's going on here. For some reason this window is not scrolling properly. I gotta fix that. I don't know what's going on here, but anyways, so the player looks like he's displaying correctly, but it's not animating. So what we want to do is actually, yeah, really what we're going to want to do is to control the things like the physics and other mechanics of how the game works within the scene. So, yeah. So, anyways, the scene basically is like the master of everything. It knows how everything works. It's the one place where we'll know where we're controlling everything instead of like controlling things from all these different places. It'll make it hard to kind of figure out where we're doing stuff in the long run. So I'll create a function called step. So it's like each like frame that we loop through. It doesn't necessarily need to be like the same amount of times as the frames that we're drawing, but each time that the game like steps once, then it can like do the one round of the checking the physics and then checking the controls and checking blah 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 whatever else it's doing, AI, etc., and also it's going to do the animations. So that's a good way to do it. Is the scene will tell the scene to step, and when the scene steps, it will tell the player one sprite image to animate. So there's going to be a better way of doing this here. So I'm going to modify it later, but right now I just want to get this thing working so we can see if it actually just has the basic functionality we're trying to make here. So we'll say in the draw function, this is what executes over and over again in the game. It's really intended to handle drawing, but with processing, and also you want to use it to call the physics and stuff like that. Oh, what was I say? I mean step. Okay, so now it's going to tell the scene to step each time, each frame that it tries to draw. It's going to tell the scene to do one step before it draws the frame. So let's see what happens here. Okay, so now you see the guy is animated. He's walking around. It looks like. Boop, 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 boop. So yeah, that worked. It's going kind of fast actually for the animation. It looks kind of cool though. Okay, so that's your basic animation right there. Okay, so, oh, yeah, I don't know what's going on here. It's kind of acting a little bit glitchy. I don't really understand what's happened. Huh. Okay, well, I'll tell you what, I'm totally stumped right now as to what the problem is, that why it's moving strangely, while it's doing this thing, why I can't move past here. It's like I'm pressing the button to go forward, to go to the right, but then when I get like far enough, it makes it automatically just start moving back, moving to the left. And the same thing happens when I try to go down to a certain extent. I really don't understand what's going on right now, but I'll do some debugging to figure that out later. But anyways, for now, let's go ahead and make this like a little bit more simplified, like what I was saying. First off, I'm just going to make a display function in here for the sprite, because that was just kind of annoying. It's going to get really annoying later on to have to type everything out like that. So you say display. It knows where its position is, so you don't have to pass in the position to make it display at. So it's gonna you're just gonna say image. I should just copy it from the top here. So you got, yeah, image.display sprite.position. I'm just gonna change this to display, and I'm gonna go ahead and complete that display function here. Okay, so image.display, and then doesn't need to say sprite, but it's just gonna say position because that's the position of this sprite. Alright, so that should make it easy. Let me go ahead and just run it again just to make sure that it's still, yep, okay, still displays the character correctly. Um, Alright, so now what I'm going to do is, remember how I was saying that we could do this sharing the animations? I'm going to create a list of player animations, and then I can set the player to one of them. That'll allow us to kind of easily exchange out the different animations that we want for the player. We'll load everything up at the very beginning of the program. That'll also make it just easier to kind of figure out like where we load everything, so that we can switch up the actual image files if we want to, just change around the graphics for the game. If we want to like improve the graphics or something like that, we can easily just go to one place in the program and make that change. So I'm gonna go ahead up here. Actually, I'm gonna create a well, similar to how I have this map tile palette. I'm gonna create essentially what's gonna be like a palette of animations for the player. So we'll call it animation player, yeah, player animations, and we can. Oh, oops. I'll put this over here. Okay. And okay, over here. So let's see. Do that after the map palette. Okay, so we'll say player animations equals a new animation list of animations. And oops, actually we got to specify the number of animations. So we'll make that just one for now, because we only have one that we're going to use. Um, and let's see. Actually, I'll go ahead and I'll make it two, because I have some other animations, and then you can kind of see how easy it can be here. So then we'll just, the same way we do with the map tile palette, we'll just set like a list here of animations that we want to load in. Um, so I'm going to actually copy this that I put here, and I'm going to put in this player animations sub 0. So the first item in that list is going to be what I want to use when I initialize that player. So I'll go ahead and set it here so that we'll say player animations 0 equals, and that's the same thing that we had there before. Um, and I'm going to put the ending parentheses there, and then we can go over here, and actually I'm just going to copy this whole thing and then put in the other animations like that. Okay, so yes, this is the frames per second, or this is the frames per second. This is the number of frames that we're passing in. So let me see here. Let me just look at what the names of this other files are, and I'll show you how easy it is to switch it out. So I'll just go ahead and copy it here because it's easier. So this is the naming convention, player1 underscore W, which is for walk, and then underscore A1, which is for armor1, because it's the images of the player with armor. So I'm just going to go ahead and paste that in because the naming convention is the same for all of these. Okay, so I go ahead and save that now. Oops, I'm sorry. Actually, this is going to be player animations 1. Okay, so now, yeah, we set the 2 player animations in this list to the to 2 different animations for the player, and so yeah, so now we have now everything should be good actually. If you remember in the player, we set, yeah, we created the sprite for the player with that player animation 0 and the position. Actually, what we're going to do now in the scene, instead of animating the actual player sprite image, what we want to do is that we want to just loop through this main list here, so that it minimizes the number of calls to that animate function that we're going to do. If you imagine that we're going to have like a ton of like enemy and item objects and stuff like that, they're all going to be animated later on. Instead of calling the animate function for each enemy that there is, there's going to be less animations than there are enemies that use those animations, if you can imagine that. So whatever. So we're going to loop through the list of the actual animations and call the animate function directly on that list instead of calling it on each player, each enemy, each blah blah blah, whatever it happens to be. So I'm going to say make a loop here for int I equals 0. I is less than oops, player and animations dot I think it's length. Yep. I what was it? I plus plus. Okay. And yeah, so for now you might think like, oh, this is maybe less efficient than just calling it from the player. That's true, but like I said, later on in the game, when we add in more stuff, it's going to become more efficient than calling it this way. So I'm going to say player animations sub I dot animate. So it's just going to loop through each of the player animations and then animate them. Um, so I think that should work. Let's test it out. Okay, yeah, you can see the player is still walking now, just like before. It still has that weird problem. I don't really understand what this causes now. I'm just gonna worry about that later though. So anyways, yeah, just focus on what I'm trying to show you guys, which is the animation. So the player is animating still. Now let's go ahead and I'll show you like how easy it is to switch up the animation for the player. So controls. Well, let's add in some new controls actually, so you can change the animation for the player. So we'll say key equals to I don't know. We got WASD for the player movement, and they'll say like K player one. What we want to do right here, we'll change the animation that the player is using. So player one dot sprite dot image equals player animations sub we'll say sub 1, and do another key here. Move that down a little bit so you can see it's different from the other ones. If key equals to, let's say L, then we'll say player animation 0. So there. So now this is how you can easily switch out the animations for the player instead of having to like load in a new one each time with all the file names and all that stuff. You already have the animations here in the list, so you can just easily switch them up, and that becomes very useful for when you're like, say like the player changes the way it looks when you pick up a specific kind of an item or something. So I'm gonna go ahead and change it. So K, boom, you see now he's wearing the armor, and then L, boom, now he's switched back to the normal animation. So that's like, imagine like the player's walking along, he picks up an item, or the player's walking along, he picks up an item, boom, and then it switches him to the armor. He picks up like the armor item and it switches him to the armor sprite. So that's or the armor animation rather. So yeah, so that's basically how we want to set up the animations in this game. There's other ways of doing it, depending on how you want your game to work, but this is just a very basic way to do it. So yeah, so anyways, in the next tutorial, actually, I'll go ahead and I'll show you guys how to load in a map file so you can make the map better. I'll try to also figure out how to fix this bug here, whatever this is, and I'll show you what the problem was in the next tutorial. So that's it for this one. Yeah, so anyways, go ahead and if you can check out my Patreon page. There you can actually download the file or you can download, there we go, you download the demo of the game that I created, the level 1 demo that I created for this game, and you can download the image files that inside of the demo, so you don't have to create your own images to do this. You can just download it out of there. I'll make a tutorial on how to actually extract the image files out of the download. You can just open up the program like it's a folder, and the image files are inside of there. So that's basically how you do it. But I'll make a video to show you how to do that. So yeah, that's it. Donate some money if you can. I'll actually release the game, and it'll be great. Thanks a lot, and have a good one. See you next time.